You design candle making kits. Each kit contains 25 cubic inches of candle wax and a mold for making a pyramid-shaped candle. You want the height of the candle to be 2 inches less than the length of each side of the candle's square base. What should the dimensions of your candle mold be? Let's set up we'll draw a picture just to start off here. We've got a square base, so let's go ahead and suppose that there's our square base of this pyramid-shaped candle, and I'm not the best artist, so you'll have to forgive me. Okay. So there's our pyramid with a square base. Let's call the length of the base x, okay? And because it's square, it's x on both sides for the length and the width. The height of the candle says that we want to be 2 inches less than the length, so that would be x minus 2. Okay. We also know that the kit contains 25 cubic inches of wax, so that's our volume. Okay. The volume of a square-based pyramid is 1/3 times the area of the base, which is x squared, times the height, which is x minus 2. Okay. The volume of any pyramid with a rectangular base, for reference, is 1/3 times the length times the width times the height. So that's what we've used here. Now, we know that our volume is 25 cubic inches, so we have 25 equals 1/3 x squared times x minus 2. So we'd now like to solve for x. Okay. First of all, I don't like this 1/3. I don't like working with fractions, so I'm going to multiply both sides of this equation by 3. And by doing that, I'll cancel the 1/3 and the 3 out. And I've got 75 equals x squared times x minus 2. And this here, we can go ahead and distribute the x squared, and we have x cubed minus 2x squared. And let's go ahead and subtract the 75 over so that we have a 0. And we're now finding the zeros of this polynomial. So we have techniques for finding the zeros of a polynomial. We have the the rational zeros theorem that tells us that the factors of 75 divided by the factors of 1 will be the rational zeros. So that's plus or minus 1, 3, 5, 25, and 75. Those are the rational zeros of 75. The rational factors, I should say. The factors of 75, and then divided by the factors of 1, which is just 1. So these are the possible rational zeros. So now we just need to start checking these, and we'll use synthetic division to do that. We've got our coefficients of 1, -2, 0, and -75. Okay, now at this point we have enough practice plugging things in and checking. I'm going to go ahead and just jump straight to something that I happen to know will work. We bring the 1 down, multiply by 5, add, we get 3. 3 times 5 is 15. 0 plus 15 is 15. And 15 times 5 is 75. Add those and we get 0. Okay, so we have now that this polynomial factors as x minus 5 times x squared plus 3x plus 15. Okay. Well, this quadratic right here, if we want to find the zeros of that, we could use the quadratic formula. (b plus or minus the square root of b squared minus 4 times a times c over 2a. Underneath the square root, we have 9 minus 60. That is -51. Well, we have a square root of a negative, which is not a real number. So when we're looking at this physical quantity that we're trying to solve for, x, which is the length of a side of this pyramid, obviously it has to be a real number. So this does not give us a solution that is actually physically meaningful in this problem. So the only zero that we have that actually means anything is x equals 5. So that's our answer for the length of our candle, x equals 5. That's the length and the width. And then the height, let's go ahead and write this, length is 5, and the width is 5. And the height, we know that the height of our candle is x minus 2. 5 minus 2 is 3. So these are the dimensions of our